Okay, so first off, for those of us who got there, which option would you pick?
The
I
pennies.
take pennies.
Why do you say pennies?
Because it eat.
Because it will go this way. Oh, it will curve up instead of go straight.
Instead of straight.
I'm pretty sure that's not a word.
Straight.
Straight, thank you. But does curving guarantee that's going to earn you more money?
No.
No, it's doubling over time.
It is doubling every time. So even though we're starting with a penny, it is doubling every time. But for those of us who wrote the equation, I think you're the only ones I saw actually plug this in. Please notice, option 1, we were repeatedly what? Adding. So a bunch of us went ahead and jumped to y equals mx plus b, slope-intercept form. Because that $4 million was the y-intercept. Now, some of us, I'm glad you remember this, you could do, starting at $4 million, what were we doing to that $4 million?
Adding 60.
That was starting point. We were adding to it, though.
Oh, you said what we do? Yeah.
$60,000 every day for X days. Are those the same thing, Kelsey?
No.
You're not even looking at it.
No, they're absolutely.
You're not even looking at it. Are these equations the same?
No.
Why not?
One has an X at the end of it. And they don't start. I mean, yeah, they say.
Which one is it?
Yes.
Why?
Same thing being done.
What do you mean the same thing being done?
60,000 times X plus 4 million.
Notice
What was all
we're
that?
repeatedly adding by 60,000 in either one, right?
Yeah.
And we're starting at 4 million in both of them. Okay, I do like this format though because it helps us with option 2. We started with 1 penny, and if you look at the table, we're multiplying by 2 x number of days. And for those of you who plugged it in, like remember, you get an equation, and Peyton was trying to do this early, I would write the equation first. You can plug in now. I believe for those who did this, we got 10,737,814. Point
Something like that.
24, I think.
No, that's so wrong.
What'd you get then?
It's not 8. It's 418.24.
Man, I'm sorry.
So wrong this game.
418. But I got the 24 right? So you mean I switched a 4 and an 8 off of memory?
You got everything,
My bad.
You got everything else right besides that.
Come on, Mr. Penny.
Yeah,
But if I plug into here, I get 5,800,000. So you tell me, which one would you take? 5,800,000 or 10,700,000?
10 million. I'd take 10
Noah?
No, I don't want to know why. I would take 10 million all day, every day, over 5 million. I would take a million just in general, but I want you to see this. Very clearly, option 2 started out with way less money, right?
Yeah.
And option 1 started out with way more money. But at some point that changed.
Yeah, it's just your tricks or math tricks, Maggie.
It's not math tricks, it's paying attention to rates of change. Now, I need y'all to pay attention because this will help you on Desmos. So if I type in 4 million, well, I never told you to do that. So y equals 4 million plus 60,000. I can't see that. Why not?
Because it's all the way over.
But you can't say it was on the 6. And you said 6 not.
There's a lot of things.
It's not a point. It's not a point. It's not a point.
Well, I don't need a point. I mean, that's an equation. That should give me a graph, right?
I don't know.
The starting point is supposed to be on the Y.
I guess it does.
Okay, the starting point is on the y-axis. What is my starting point here?
64 million.
$4 million, right?
And there's no way to put on there.
I go up to 8. We need to pay attention to these things because, like, okay, I need to change my axes. Also, what day am I supposed to be going out to? 30. I'm only at day 10. Now, do I care about all these negative days?
No.
No. So we want to pay attention to our scaling on the axes. So I'm going to go like -5 to like 35. That way I get past the day 30. The y-axis, how many? I need to get pretty big. I'm literally starting at 4 million. So I'm going to go significantly bigger than that. So maybe
20 million.
10 million?
Quadruple.
3, 1, 2, 3. And I'm going to go ahead and start this at like -20,000.
That's a lot.
Okay? So there it is. There's the first equation. Now let's look at the second one. 0.01 times 2 raised to the x.
Told
Man.
ya. Told ya it curved and
It basically doesn't even seem to exist for 25 days.
Yep.
But what's happening every single day?
double.
It's doubling. So once it starts to show up, it's going to double pretty quickly, right? So this is why it matters that we understand systems of equations. When would you take option 1?
In the short term.
The first 25 days.
Well, even the past,
24.
so 26 would be here. I'd still take option 1.
Then
Where's
so
the intersect? Click on it.
There we go, right? That point of intersection where we have the same value on the same day.
What is it?
That's day 29. They have the same amount of value, somewhere around 5.7 million.
dang.
So before day 29, which option am I taking?
The red one, which is
One.
formula for A, the first one. Option 1.
After day 29, I'm taking.
Option 2.
Straight up.
So is it important to be able to, one, understand a system of equations?
Yes.
Because if I need to know, like if I'm before day 29, yeah, I'm taking option 1. But if I'm after day 29, if I'm looking at that point of intersection, I'm definitely taking option 2. That point of intersection matters. And you remember how we've been doing substitution for the last, I don't know, few days with Mr. Lipham?
Yes.
You know what you can't do when it's exponential and linear? You can substitute, right? I could literally plug this in for y, right? Y equals this thing. But unless I'm just unaware, which I know a decent bit about math, there is no way to use inverses to solve this equation. So if I can't do it algebraically, if I can't solve it algebraically, what would I need to use? A graph or a table or something like that, right? So that graph, that point of intersection, will always help me find the solution to the system. Does that make sense?
Yeah.
Do we see why this point of intersection is important?
Yes.
Do we understand also why it's important that we get seated and ready for class before the bell rings?
Yes.
Because if we do that, we don't have to go into enrichment.
Yeah.
But I don't feel bad going into enrichment when we're not doing what we're supposed to do before class. Is that clear, Corell? Okay. Peyton, Kelsey, all of us, we got to be ready for class when the bell rings. Cool? Feel you. Alright, here's your homework.
When you get the code back.
I don't have eyes.
Wait, no, don't complain. Don't complain.
Don't have eyes.
What's gonna happen when you get the code back saying if you had a bad reaction to it? Because you already make those noises on the regulars.
I know, right?
I'm be good, Chandler.
You do that every
You
day.
already-
It's gonna be like Kelsey's in the Matrix. Have y'all even seen the Matrix?
Yes, I have.
No,
Good.
I'm not.
It's a great movie. If you've never seen the Matrix, fix that.